Hi, hello everyone. So today is just a quick little video, and what I'm going to do is I'm going to try my best to show you a kind of a working version of it, for want of a better word, of the fetch, decode, execute cycle using the VonNeumann architecture. So just we'll do a quick VonNeumann one. Okay, we start with a control unit. Okay. And we'll throw in a program counter. So this is a control unit with a program counter. Okay, just put it down in the corner. And we put in an ALU unit. Put in an ALU unit. We put in an accumulator. And we can throw some cache in here as well. So remember, know your difference in your cache and all that. Throw in some other registers here. Why not? And we put in, what was it, an MA, what was it again? MAR and an MDR. Okay, MAR and an MDR. Okay. I would throw some memory in. Okay, so memory. This is your CPU. That's your memory. Okay, and remember, output. Input. And then you have your memory going two ways. Okay, so we have our memory. Now we put our arrows in. I might use a different color here. Arrow going this way, arrow going this way. Okay. This way. Okay, so let's start with the memory. Okay, so this memory is going to contain a program. Okay, so we'll do the simplest type of program possible. This is going to contain the address. Okay, and this is going to contain the data. So we'll put in simple address 1, 2, 3, 4, 5, and 6. Okay, so what's the first thing? I'm just going to use an example I've used before. Load address 5. Okay, add address 6, store in address 6, and end. I'm just going to put 10 and 15 there. So what happens? Okay, so at the very start, the program's counter is set to 0. Okay, so when it clocks on, the first one it's going to go is 1. So it's going to send a signal to the memory through the MAR, memory address register. Okay, and it's going to say, look in address 1. Okay, and it's going to fetch what's in address 1 and bring it to the memory data register. So what comes into here is load address 5. Okay, you with me so far? So this is at 1. It sends to the memory address register, go to address 1. So it goes to address 1, finds what's in it, brings it into the memory, sends that signal to the memory data register, load address 5, which sends it into the ALU. Okay, so in the ANU now we have load address 5. In the meantime, the program counter has kicked on to 2. So now it's on 2. Okay, now in here we have load address 5. The control unit will decode load address 5 and decide what to do with it. Okay, the first thing it'll do is it'll keep a copy in the cache for future reference. Okay, and then it'll tell the memory address register to find what's in address 5 and load it. So memory address, remember, we're still on the first cycle. Even though the counter has moved to 2, the control unit is still dealing with the first cycle. So it goes to address 5, takes the 10, brings it into the memory data register, and pops 10 in here and keeps a copy. So now we have 10 in here with a copy, and we've finished the full first cycle. The program counter is now on 2. It sends a signal to the memory address register to look into and get it. Looks into, it says add address 6, brings it down, fetches it to the memory data register, which pops it in. The control unit looks at it. At this stage, the program counter has already moved on to 3, but we're still on the cycle 2, which is add address 6. So again, it decodes it, and it says it has to do 2 things. Get address 6 and then kick in the AL unit and add it. So it does that. It sends the signal out to get address 6, which is 15, bring it in, and then the ALU will add 10 and 15. Remember, copies are being kept in the cache all the time of all these instructions for future reference. It's already on 3. What does 3 tell you to do? Store it in address 6. So whatever answer I've got from my first 2 cycles, I have to take it now and read it in. So now the 15 becomes 25. Remember that at this stage, after the 3rd cycle, this is already on cycle 4. So once the 3rd cycle is completed and that's been written in as 25, the program counter executes address 4, sends it to the memory address register, which fetches address 4, which says end, sends it into the memory data register, which passes it through. The control unit will decide what to do with it, and no more cycle. So now you've added 10 and 15 as 25. Okay, so it does look a little bit confusing. It does, especially when you think, well, how is this all happening at the same time? But you have to remember, there's CPU, this is 1 core. You could have 8, 16, 32 cores. This is happening billions of times to make all these calculations happening. So I'll quickly go through the process again. Address 1 in the program counter sends that signal, address 1, to memory address register, which fetches what's in address 1 and transfers it into the memory data register. So what comes into memory data register is signal to load address 5. Meanwhile, the program counter is ready on 2. So it just has a 2 in there now. It'll do nothing. It will do nothing until the cycle for 1 is complete. So in here we have load address 5. It comes into the CPU, okay, and the control unit decides, does it need to be added, subtracted, multiplied, divided, or is there another instruction in there? And there is another instruction. There's a fetch instruction. It says load address 5. So it will send a message through the MAR to the memory to find 5, bring it into the MDR, and store it in the accumulator or wherever, and keep a copy in the cache. Everything that comes through the MDR back in is kept in a cache. Okay, so now we have 10 in here somewhere, but there's no instruction to do with 10. Look, 10 doesn't have any instruction with it, so it's just there. That means 2 now can kick off. 2 means load address 6. Sorry, add address 6. Okay, so that's what will happen. It'll take what's in address 6 through the system, but when it gets to here, rather than stop, because if it's a number, it'll just stop. But it's not just a number, it's do something to the number. So once that comes in here, the control unit will determine, okay, ALU, you need to add those 2 numbers. add the previous one to this one, keep a copy, okay? And then there's nothing else to be done because that's add done. It's already on 3. It does what 3 says, which is take the answer from cycle 2, which now is 25, and pop it in instead of 15. And then that moves on to 4, and then 4 is just end. So that's how it works. Okay, it's just a little one just to get your heads around it. Okay, thank you very much. Goodbye.